Sum and difference identities. We have here a unit circle with point P at the x-axis with coordinates 1, 0. From the origin, draw a line segment that has an angle B with respect to the x-axis and point Q with coordinates cosine B, sine B. From the origin, draw another line segment that has an angle A with respect to the x-axis and point S with coordinates cosine A, sine A. Then connect point S and point Q with a chord. So if we call our origin as point O, then we have a triangle SOQ. Then out of this make another similar triangle but with one side lies on the x-axis as shown. If angle SOP is equal to A and angle QOP is equal to B, then angle SOQ is equal to A minus B. And since angle TOP is from angle SOP, so angle TOP is equal to A minus B also. From this, we have the coordinates of point E as cosine A minus B and sine A minus B. And notice that chord TP is equal to chord SP. From this, the horizontal component of chord TP can be obtained by subtracting cosine A minus B and 1, the cosine coordinate of point P. While the vertical component of chord TP is sine A minus B. We mentioned that chord TP is equal to chord SQ. The length of chord TP by Pythagorean theorem can be obtained as the square root of cosine A minus B minus 1 squared plus sine A minus B squared, and this is equal to chord SQ, which can be obtained as the square root of cosine A minus cosine B squared plus sine A minus sine B squared. We can remove the radical sign by squaring both sides of the equation. Cosine A minus B minus 1 can be expanded as binomial square, and you can square sine A minus B. Cosine A minus cosine B and sine A minus sine B can be expanded also using binomial square. Then we can simplify by combining identities that can be 1, like cosine squared A minus B plus sine squared A minus B on the left side, and cosine squared A plus sine squared A and cosine squared B plus sine squared B is on the right side. So on the left side we have 1 plus 1 minus 2 cosine A minus B is equal to the right side, which is equal to 1 plus 1 minus 2 cosine A times cosine B minus 2 sine A times sine B. 1 plus 1 is 2, so 2 minus 2 cosine A minus B is equal to 2 minus 2 cosine A times cosine B minus 2 sine A times sine B. Transposing 2 on the left side, we can subtract with the 2 on the right side, which is equal to 0. Then divide both sides by negative 2. We have cosine A minus B is equal to cosine A times cosine B plus sine A times sine B, or cosine A minus B is equal to cosine A cosine B plus sine A sine B. So the cosine of the difference of two angles is equal to the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. For cosine A plus B, this is the same as cosine A minus negative B. And this is equal to cosine A times cosine negative B plus sine A times sine negative B. From negative angle identities, cosine negative B is equal to cosine of positive B, and sine of negative B is equal to negative sine of B. Negative times negative is positive, so the final answer is cosine A cosine B plus sine A sine B. From cofunction identities, sine theta is equal to cosine 90 degrees minus theta. In the same way, sine A plus B can be expressed as a cofunction identity as cosine 90 degrees minus quantity A minus B. Using associative property of addition, you can group as 90 degrees minus A minus B. And this is equal to cosine 90 degrees minus A times cosine negative B minus sine 90 degrees minus A times sine negative B. Sine of negative B is equal to negative sine B, and cosine 90 degrees minus A is equal to sine A. So sine A plus B is equal to sine A cosine B plus cosine A sine B. For sine A minus B, this can be equal to sine A plus negative B. From the sine of A plus B, we can derive this as sine A cosine negative B plus cosine A sine negative B. From negative angle identities, cosine negative B is equal to cosine B and sine negative B is equal to negative sine B, so the final answer is sine A cosine B minus cosine A sine B. For tangent A plus B, and this is equal to sine A plus B over cosine A plus B. Then substitute to sine A plus B over cosine A plus B the derived identities. Then divide both numerator and denominator by cosine A cosine B. Simplifying, we have the final answer as tangent A plus tangent B over 1 minus tangent A tangent B. In the same way, tangent A minus B is equal to tangent A minus tangent B over 1 plus tangent A tangent B. Please subscribe to this channel. Hit the notification bell. Like, comment or share. Thank you very much.